Hi everyone. Hi everyone. Again, welcome back to the channel called Engineering Beyond Blueprints. As we discussed in our previous video, we talk about the transformer and definition of it, and we talk about what is the usage of it, and what are the applications of it, and what are the different critical parameters, and what are the comparison between the existing and the recommended solution when we choose the right alternative solution. So given that said, again, as I said, we are getting into the another important topic called inductor. So as I said, inductor is a passive electronic component that stores the energy in magnetic field when electric current flow through it, right? So then you might be wondering what is the difference from transformers and the inductor. So transformer is kind of transfer the energy from primary to secondary coil with again different part of the component where there is a need of source or voltage or current. So similarly in the inductor, what has happened, it kind of stores the energy in the magnetic field when the electric current flow through it, right? So again, like as a basic parameters, as we discussed in the previous, like even for inductor also we do have critical parameters. So we kind of measure this into I mean, as unit of measurement is Henry, so that's what I would say. And again, we do have different types of transformer based on the construction, based on the usage. So when we start with discussing about the based on the construction, there are around five inductors based on the construction. We would say one is air core inductor and iron core inductor, ferrite core, toroidal inductor, and multi-layer and SMD inductor. So this is widely used nowadays in many of the applications, right? So when again, like when we look into the usage part of it, we use in as usual, like we talk about transformer, right? Same thing, like these are the inductors are used in power application, RF applications, and EMI and common mode chokes and differential mode chokes and filter inductors, so where there is a required of filtration, right? So these are the places where we are using. So by coming to the parameters, so always, as I said, inductance value should be the same, should not be deviate, and tolerance is equal is better, right? And if higher side of tolerance you are getting, then this is kind of less precise, I would say. Lesser the inductance value, or sorry, lesser the tolerance value is always better. So next comes DCR, right? DCR is like a DC resistance. Yes, lower is preferred much because it should be having very good resistive capabilities. And next comes for current rating. So it should be same or higher side of it is better. Like as we talk about in transfer also same thing. This is one of the important parameter here as well. So next comes saturation current. So saturation current means the value. For instance, if you say 2.5 amps or 2.5 milliamps, whatever with the unit of measurement, always you try to find the equal value or try to find the higher value. Does it mean that it's going to be withstand even though there is a high flow of current through the inductor? So next comes self-resonant frequency, we call SRF largely. Higher value is better, right? So lower value is not be preferable. And one more, exactly, that's what I was talking about, Q factor. So Q factor is something like the factor of the quality of the material or the whatever the windings that has been used. So that is mainly define the Q factor of the inductance. So there should be always equal value you should be select, right? It should not be higher side of it. So core material, as I said, depends on the application. Always try to prefer to have the equal same core material rather going with the lower version of it. Always try to go for higher version of it As we go the good core material, then it's costing us more. Again, like depends on the application, you have to choose which is best suited for the application. So next come for size, right? So inductor size, again, definitely is going to be mounted on some chassis, or depends on the application. If it is SMD, it's going to sit on the PCB. The size of the package of the particular inductor, including the pitch and the hole or maybe die of the pins should be matched. It should not be deviate. So that is pretty much summary of inductance. This is there is no more talk about on the parameters. As a part of conclusion, if you ask me, inductors has been store the energy in the magnetic field and oppose the change in current. And second thing is choose the inductor type based on the construction and the application. As I said, it depends on application and the usage. We have to choose whether we are going with the inductor or could be a transformer. For sure, definitely we need to choose based on the application type. And we have been talk about all the comparison parameters. So when we are selecting alternative, you should must follow the as per so far we discussed on this video. With that said, I think I hope this help a lot for the who design the board or design the entire application, and even for the component engineering who bring the changes in the application. So they play a critical role, and as I said, they are the heroes for when there is a recommended solution for a given obsolete component. So, with that said, I had been covered all the passive components, which are majorly four different type of passive component. And in the coming video, I would like to talk about more on electromechanical components, which I want to talk in the next video. With that said, I hope this video helped a lot, and all the best. And keep watching. Please do motivate. If you had any kind of feedback, please do share it with me so that I can come back with more update and bring the more content which is relevant for your usage and for understanding. Thank you so much and have a great day.